the factors in details. Okay, the three factors that will give effect to the rate of a reaction. It is in the page of 720 of your textbook. Look at to 720. Okay, 16.5 theories of a chemical kinetic. Okay, so this is the detailed explanation on the concentration factor and also the temperature factor, why they affect the rate of a reaction. Okay, so the first factor is the concentration factor. Why concentration of the reactant increase? Okay, concentration of the reactant increase will lead to increasing of rate. Okay, this is actually based on the basic principle of the collision theory. Okay, that state that the particles must collide in order for them to react. Okay, the collision theory said that for the reaction to occur, before the reaction can proceed, okay, the reactant particles must collide first. Okay, the collision need to be happen first before they can react. Okay, so of course that when we increase the concentration of the reactants, okay, the number of reactant particles will increase, the number of collision also increase, and then the product will increase, the rate of a reaction will increase. Okay, look at to this figure. Okay, if let's say we have a reaction between the yellow particles and the gray particles. Okay, we have two atoms of A and two atoms of B. Okay, this is if we have only two versus two. If we have two atoms of A and two atoms of B, the frequency, the number of possible collision that can occur will be 4. Okay, the first A collide with the first B. First A collide with the second B. The second A collide with second B. And then the second A collide with the second B. Total collision will be 4 collisions altogether. Okay. And then if we add another 1 particles of A, now we have 3 particles of A and 2 particles of B. Okay, the number of collision become 6 collision. Okay, from 4 we add 1 particles, the number of collision becomes 6. And when we add another 1B, so now we have 3 versus 3. Okay, 3 particles A, 3 particles of B. The frequency of the collision become 9 collisions. Okay, we add only 2 particles. Okay, we add only 2 particles. The number of collision is more than doubles. From 4 collisions, then it turns to 9 collision. Okay, so we said that from the collision theory just now, in order for the reaction to occur, before they react, they have to collide. So when we add the number of, when we increase the concentration, okay, we know that it will increase the number of reactant particles. Okay, reactant particles will increase. So when the number of reactant particles increase, what will increase is the frequency of the collision. More collision will occur, or the collision occur more frequent. Okay, lagi banyak collision yang berlaku. When we increase the concentration, the reactant particles increase, collision increase, then the rate of the reaction increase. Okay, this example in this figure shows us if we add only 1 particle to 1 particle. When we add the concentration, for example, from 1 molar, we increase it to 2 molar. It is not we add 1 particles. Okay, from 1 molar to 2 molar, we are adding actually 1 mole. 1 mole is 6.02 exponent 23 particles of the reactant. Okay, please imagine when we add 2 particles from 4 collision, it turns to 9 collision. Now you add 6.02 exponent power of 23. Okay, please imagine how many particles that we have and how many collisions that will be increased. Okay, that is why, okay, this is the consequences when we increase the concentration of the reactants. the number of reactant particles will increase. Okay, so when the number of reactant particles will increase, then the frequency of the collision will increase. When the frequency of the collision increase, then the frequency of the effective collision will increase. Okay, when the frequency of effective collision increase, then the rate will increase. Okay, this is the consequences. Okay, when we increase the concentration of the reactant. Okay, we look at what is the effective collision. Okay, in order for the reaction to occur, okay, we know that from the collision theory, reaction nak berlaku, reactant particles kena collide. But it is not necessarily that for every collision that is occur, they will react. Okay, there are two requirement for the collision to be effective or for the collision to lead to the product. Okay, we have two type of collision. It's either effective or ineffective. Okay, you can look at in the page of 721. Okay, figure 16.152. Okay, collision, it's either it is effective or not, or ineffective. Okay, so two factors for the collision to be effective. Firstly, the collision must occur with enough energy. Okay, how much enough? Enough is when the collision occur and achieve activation energy. Okay, and then the second requirement for the effective collision is the collision must occur with the appropriate molecular orientation. Okay, these are two requirements for the effective collision. Okay, first, effective collision must have enough energy or the collision must achieve activation energy. Second is the collision will occur with the proper molecular orientation. Okay, let's look at to the first requirement. Okay, the collision must occur with enough energy or the collision must achieve activation energy. Okay, this is an example. Okay, when we have a high jump, okay, and we compare it with the activation energy. Look at to figure 16.17. It is in the page of 723. Okay, so if let's say, let me give other reactions by using this figure. Okay, if let's say we have a reaction of A plus B produce C. Okay, in order for the reaction to occur, we said that the particles must collide. Okay, so if we have the first set of collision in which their energy, this is A, collide with B, okay, and this is their energy levels. Okay, look at to the graph. This is the potential energy versus reaction progress. And then the second set of the collision, okay, when their energy is here, A and B. Okay, and then the third set of collision, okay, this are their energy. Okay, and then the fourth set, this is their energy. And the fifth set is this. Okay, out of these 5 sets of collision, only 2 that are effective. 1, 2. Okay, if we numbered them, okay, this is A, B, C, D, E. Okay, A, B, C, D, E collision, only D and E that will lead to the product. Okay, because only these 2 sets of collision that achieve activation energy. This is the activation energy. So this is what I said. Okay, the first requirement for the effective collision is the collision must occur with achieving activation energy or with enough energy that achieve activation energy. These three sets, they tak achieve this activation energy. Okay, this is the potential energy diagram. You have learned this before. Okay, activation energy is from the reactant level until this state that we call this state as the activation state or transition state. Okay, so semua kena achieve the activation state ni or transition state, then they will produce a product. See here. Okay, so this is the first requirement, achieve activation energy for the collision to be effective. And then the second requirement for the effective collision is the collision must occur with the appropriate molecular orientation that can be observed from this figure 16.5. Okay, if we look at to this figure, it is a reaction between nitrogen monoxide and nitrogen trioxide. Okay, we said that the reactant must collide for them to react, but it is not necessarily for them when they collide, then they will produce a nitrogen dioxide, not necessarily. Okay, the collision must occur with the appropriate molecular orientation. Okay, look at to the first set. 1, 2, 3, 4, 5. There are 5 sets of collision that is given. Okay, this is nitrogen monoxide. This is nitrogen trioxide. Okay, so the first collision is between these red particles and the red particles or the oxygen in the nitrogen trioxide, oxygen, nitrogen, monoxide. They collide this way, okay, at this orientation. Then it is ineffective collision. The second set of collision when this oxygen, okay, collide with nitrogen at the center of the nitrogen trioxide. Also ineffective. Ineffective means that do not lead to the product. It will bounce back and become reactant back. Okay. And then the third set is the nitrogen, okay, attack or it collide with the nitrogen in nitrogen trioxide. Nitrogen, nitrogen, ineffective as well. And then the third set is the nitrogen with this oxygen, ineffective. Only the last set, when the nitrogen, okay, collide with this oxygen at this orientation, okay, in space, then it form two nitrogen dioxide products. Okay, this is what we said that the collision must occur with the correct molecular orientation. Orientation tu penting. Okay, kalau orientation salah, then dia tak boleh nak react. Okay, kedudukan molecules in space. Okay, that are two requirements for the effective collision. Okay, that is why when we said that, okay, when we increase the concentration, okay, we increase the concentration, the reactant particles increase, the number of collision increase. Of course, that when the number of collision increase, the chance to have more effective collision also increase, then the rate of the reaction will increase. Okay. And then the second factor that we want to discuss is the temperature factor. Okay, why when we increase the temperature, then the rate of the reaction increase. Okay, if you look at to the textbook, okay, it said that the temperature give a dramatic effect. Okay, look at to the term that is used. Okay, the temperature give a dramatic effect to the rate of a reaction. Means that if we increase the temperature by 10 degrees C only, this not we double the temperature, we just increase it by 10 degrees C. For example, from 273, we increase it to 283 Kelvin. Okay, then the increasing of this 10 degrees C or 10 Kelvin of the temperature will doubles or triples the rate of a reaction. Okay, it is doubles or even triple the rate of a reaction. That's how the temperature give effect to the rate of a reaction. Okay, different effect than the concentration. Okay, concentration, we doubles the concentration, then sometimes it is double, sometimes it gives no effect. Okay, but not as dramatic as the temperature effect. Okay, then let's look at what happens when we increase the temperature. Okay, there are two effects of the temperature increase. Okay, the first one is to the collision frequency. Second is to the collision energy. Okay, of course that when we increase the temperature, okay, will make the kinetic energy of the particles increase. This is what happens when we increase the temperature. Okay, the kinetic energy of the particles increase. So we know that the higher the energy of the particles, then the more frequent the collision occur. The number of collision or the frequency of the collision will increase. So when the frequency of the collision increase, then we know that the frequency of effective collision will increase, the rate of a reaction also increase. Okay, that is the first effect of the increasing temperature in terms of the frequency. The second effect of increasing temperature is to the energy of the collision. Okay, if you look at to the textbook, it's page 725. Collision frequency, it said that, okay, calculation shows that a 10 Kelvin rise in the temperature from 288 to 298 will increase the average molecular speed by 2%. Okay, which would lead at most 4% increase in the rate of a reaction. Okay, we said that when the temperature increase, it can doubles or triples the rate, right? Okay, but if we just focus on the frequency effect of the temperature, then it just increase 4% of the rate. If let's say the temperature increase by 10%, by 10 Kelvin, doubles the rate, means that dia bertambah 100% kan? It doubles. Tapi 4%, only 4% that is contributed by the number of the collision that is increased, the frequency of the collision that is increased. So from where that 96% lagi tu? Okay, that is actually the effect on the collision energy. Okay, so the collision energy give a major effect actually to the rate of a reaction when we increase the temperature. Okay, this is because when we increase the temperature, the fraction of the collision that achieve activation energy, that achieve EA, will increase. Okay, so the conclusion is here, at the higher temperature, fraction of the collision with the sufficient energy or equal and greater than EA, okay, will increase. Therefore, the rate of a reaction will increase. Okay, can be shown in this figure. Okay, the fraction of the collision versus collision energy, or we call this graph as the Maxwell-Boltzmann distribution graph. Okay, so from this Maxwell-Boltzmann distribution graph, this is a favorite question in exam. Okay, to show the effect of the temperature to the rate of a reaction. Okay, so if let's say we have an initial temperature, the reaction occur at T1. Okay, look at, focus to the graph of T1. And then this point is the activation energy. Okay, the fraction of the collision that exceed this point, then they are achieving activation energy, then they are effective collision. Okay, because the criteria of effective collision that we have discussed just now, there are two. First, the collision must achieve EA, activation energy. Second is the collision occur with the proper or appropriate molecular orientation. So this is the EA. Okay, so the fraction that is greater than this point, that exceed this point, then we said that they achieve activation energy and they are effective. So this fraction before activation energy, they are all ineffective. Okay, then they will come back as a reactant, bounce back and become a reactant after they collide. Okay, and then for the same collisions, if let's say area under the graph is 100 collisions, for the same reaction vessels, okay, that have 100 collisions, we increase the temperature, okay, at T2. So this is the graph when we have increased the temperature, 10 degrees C for example. Okay, so after we increase the temperature by 10 degrees C, then we observe that the graph is moving to the right. Okay, then the peak, we compare the peak of the second graph is lower. Okay, why it is lower? Because the graph is moving to the right with the same area in the first area under the graph of the first temperature and second temperature are the same. Okay, so if we focus on the second temperature only, okay, the right one, we focus on the second temperature, the activation energy value are the same in whatever temperature that we have. So when the temperature is increased, now these are the fraction that achieve EA. Okay, the fraction that achieve EA now greater than before. Okay, as compared previously, ni je yang achieve EA. Okay, so when the fraction of the collision that achieve EA greater, okay, it means that the number of effective collision increase, then the rate constant will increase, the rate of a reaction will increase. So this is the conclusion on the temperature effect. Okay, when the temperature increase, based on this graph, when the temperature increase, then the fraction of collision that achieve EA increase, so that effective collision increase, the rate constant increase, then the rate of a reaction will increase. Okay, so these are the consequences of the temperature effect. Okay, you also need to be able to explain the temperature effect in terms from the Arrhenius equation. Okay, the Arrhenius equation is in the page of 725. Okay, look at to the Arrhenius equation in the page of 725. So the Arrhenius equation is K equal to AE exponent negative EA over RT. Okay, so look at to the relationship between the K as the rate constant and also the temperature. From this Arrhenius equation, we will not apply this in calculation. We just look at to their relationship only. Okay, you need to be able to explain the relationship between the temperature to the rate based on Arrhenius equation. Okay, so from this Arrhenius equation, we observe that the temperature is the denominator of the negative exponent. This is exponent negative and the temperature is the denominator of it. Okay, to the rate constant. So since that it is the denominator of the negative exponent of the rate constant, means that when we increase the temperature, it will make K increase. Okay, from this Arrhenius equation. So how to explain the effect of the temperature based on Arrhenius equation is simple. It is even simpler than before. When the temperature increase, okay, the rate constant increase, rate will increase. Okay, this is the effect of the temperature based on the Arrhenius equation. Let's move to the last one, the catalyst. Okay, catalyst also the fourth factor that will affect the rate of reaction that we haven't discussed yet at first. Okay, so if we are using catalyst, then the rate will increase. That is what we have discussed before. Okay, so what is the catalyst? Catalyst, it is a substance that increase the rate of a reaction, okay, without being consumed. Okay, that's the definition of the catalyst from our textbook. It is the substance that will increase the rate of a reaction without being consumed. Then how the catalyst increase the rate of the reaction is by providing alternative pathway. Okay, and that alternative pathway, that alternative method will have a lower activation energy, okay, than the pathway that have no catalyst. Okay, it provide alternative pathway that have a lower activation energy, and that is why, okay, when we are using catalyst, it will increase the rate of a reaction. Okay, and then another point that we have to remember about the catalyst is if we have a reversible reaction A that can produce B and can reverse back to A, If you have a reversible reaction, the speed of the forward, okay, producing B, and then backward, B producing A, okay, will be increased, okay, both way, okay, forward and reverse. And then the next point that we have to remember is the catalyst used give no effect to the enthalpy change. Okay, this is the energy of a reaction and also the yield of the reaction. Okay, it means that if, let's say, without catalyst, from the calculation, we are supposed to get, if A turns to B, without catalyst, we are supposed to get 20 gram of B produced. Okay, with catalyst, we also will get 20 gram of B. It will give no effect to the yield. Okay, how much the amount of the product that will produce will not be affected by the catalyst. Okay, but the catalyst will mix. This 20 gram will achieve faster. Okay, we will get this 20 gram faster. This, okay, can be observed by this potential energy diagram. We have seen this before. Okay, when we talk about the effective and ineffective collision. Okay, so this is the pathway from A and B to turns to the product. Okay, A and B turns to product. Okay, without catalyst, it will use this pathway. Okay, and we said that for the products to be formed, the collision must achieve the activation energy. Means that from this point until this transition state. Okay, so the collision must achieve this EA. Then it will turn to product. However, when we are using catalyst, the catalyst will provide other or alternative mechanism or alternative way to produce to the product. Then we look at to this alternative pathway. Okay, the EA even lower than the first EA without catalyst. So of course that when we have a lower activation energy, then the reaction will be faster to lead to the product. Okay, if we imagine it by using the collision just now, we have 5 sets of collision. Okay, this is the first set, this is the second set, this is the third set, this is the fourth, and the fifth set. Okay, by using the original pathway, by using this method without catalyst, only 2 that will be effective, that will lead to the product. Okay, however, when we are using catalyst now, this third set also can achieve to the product that can be effective. Okay, this is how the catalyst give effect to the rate of a reaction. Okay, catalyst will provide alternative pathway that have a lower activation energy. Okay, in this example, given to us the alternative way having 2 peaks, ada 2 peak. Okay, shows that the mechanism involve 2 steps. We'll discuss what is mechanism after this. Okay, as for the initial way, it is only have 1 peaks. Okay, so kalau you got a question, okay, shows the effect of the catalyst by using this potential energy diagram by the aid of the diagram. Okay, you can just have 1 peak in the catalyzed punya diagram. Okay, I redraw back. Okay, it is the potential energy versus reaction progress. Okay, so if let's say this is the uncatalyzed one. Okay, so the catalyzed one start from the same point, but it is lower and end at the same point. Okay, and then you have to label. Okay, this is EA2, the second activation energy. Okay, and then this is the EA1. Then you also need to label that. Okay, this is uncatalyzed or without catalyst. As for this one is catalyzed one. Okay, and you have to mention that EA1 is greater than EA2. Okay, this is how you answer question 21. Okay, sketch a label diagram to illustrate the effect of catalyst activation energy of the exothermic reaction. Okay, question 21 of the tutorial workbook. Okay, you have to draw the structure, the figure, sorry. Okay, the potential energy diagram figure. Okay, so about catalysts, okay, you have to know that there are two types of catalysts, homogeneous and heterogeneous catalysts. Okay, homogeneous is the catalyst that exists in the same phase as the reactant. Okay, when the phase of the catalyst is the same as the reactant, then we say that it is the homogeneous catalyst. Example, if we have a reaction of A gas, B gas turns to C gas. Okay, you are using X as the catalyst, and this X is in a gaseous state. So we said that this X is the homogeneous catalyst. Okay, and the second one is the heterogeneous, is when the catalyst is not as the same phase as the reactants. Example, if your catalyst acts in aqueous state, okay, or it is in a solid state, okay, react with A gas, B gas. So the phase is not the same as the reactant, and then we said that this catalyst is a heterogeneous catalyst. Okay, so that's all on the catalyst. Okay, catalyst, you need to be able to explain, okay, how the catalyst gives effect to the rate, okay, by providing alternative pathway, okay, that will give a lower activation energy. Then the rate constant, before that, the catalyst also change the rate constant value. Okay, so the consequences will be catalyst used, okay, will increase the fraction that achieve collision, fraction that achieve activation energy, will increase. Okay, from two sets only, now we have three sets that achieve EA. Okay, how it achieve activation energy? By providing alternative pathway. Okay, so when the fraction that achieve activation energy increase, then the frequency of effective collision will increase. And then the rate constant will increase, rate will increase. Okay, so this is the effect